Continuing on, a spotlight on the ground shines on a building 80 feet high. Let's say the building looks like this. And a spotlight, let's say the spotlight is, oops, wrong one. Here we go. Okay, that's not going to work. Here we go. Let's say this is the spotlight, and this is 80 feet. It's shining on the building. A man 6 feet tall, a 6 feet man, okay, 6 feet tall, walks toward the building from the spotlight at a, so let's say the man is right there, and the man is only 6 feet. So as the man walks, do you see the shadow on the building? So to the building from spotlight at speed. So if I call this x, then I know that the x dt is 5 feet every second. How fast is the length of the shadow on the building decreases when the man is 15 feet from the building? A spotlight on the ground shines on a building 80 feet away. Oh, 80 feet away. I'm sorry. This is not 80. I was going to say I didn't use that for anything. This is 80. So if this is x, this distance is 80 minus x. Okay. How fast is the length of the shadow? So how long is this shadow? As the man gets closer to the building, this light will, the shadow will shrink down. When the man is 15, how fast is the length of the shadow when on the building? How fast is the length of the shadow on the building decreasing when he is 15 feet from the building? Okay, 4 meters from the building, does that actually equal 15? 15 meters from the building. So if I am 15 meters away from this, so remember, this whole distance is 80. If I am 15 away from the building, that means x is what? X is 65. When x equals 65. So that's the only thing I have to adjust. Now what? Now I look at those two triangles. I look at this triangle, that one, and I look at that one. So the yellow one says there is s, this is 80, s to 80 equals, and the green one, the smaller one, is 6 to x. There it is. So that's the equation. I need the equation. Well, if I cross multiply, sx equals 480. And now if I take a derivative, I will get ds dt times x plus s times dx dt equal as 0. And what I'm looking for is ds dt. So ds dt times x, well, we said x was 65 if you are 15, the way I set the problem up, if you are 15 feet away from the building, plus s, and I'll get s in a minute. Dx dt, the man is moving at a rate of 5 feet per second, equals 0. And let's see how that works. Well, what is s? If this is 6, nope, take that back. If this is s, okay, it's not registering for, okay, right. So what is S? If x equals 65, I put that there, then S would be 6 times 80 divided by 65. And we said dx was 5 equal to 0. Well, 5 divides 13, so the s dt will equal negative 448 divided by 13, and if you multiply by 1 over 65, and that reduces, of course, and the units would be feet, because that's length, per second. Again, you could throw this in a calculator and figure out what this is. A car is pulled onto a tow truck, one of these tow trucks, by a chain. So the tow truck is dragging the car up by a chain attached to the front of the car. Let's say this is the car, and passing through a pole. Okay, I see. So something like this. A pulley on the truck that is 2 meters higher than the front of the car. So the pulley is 2 meters higher than the front of the truck. That's fixed. If the chain is pulled in at a rate, call this x. The x dt is 3/2 meters per second. How fast is the boat approaching? You know what? Here. I don't want to use s because my s's look like 5s. But if I call this x, then the x dt is what I'm looking for when approaching dock, when x equal 4 meters. Well, let's see. How are those related? S squared equals 2 squared plus x squared. If I take a derivative, 2s ds dt equals 0 plus 2x dx dt. The 2's cancel out. And let's see what we're looking for. We're looking for the x dt. The x dt, this is really what we want. So I need to get rid of the x. I need to get rid of the s and the s dt. Well, the s dt is actually 3/2. We got that. And now, if this is 2 and this is 4, isn't s squared 16 plus 4, which is 20? So wouldn't s be the square root of 20, or 2 radical 5? And what's x? 4. So the x dt would be, so this is 2 radical 5, the 2's cancel out, that's 3 radical 5 divided by 4, and what would be the units? So x would be in meters per second. That's how fast the car is approaching the truck. So coming up with the equation is almost half of the problem. A particle moves along this path. As the particle passes through the point at 2/3 pi over 3, that's a half, that's 2. Its x coordinate decreases at a rate of 5 centimeters per second. How fast is the distance between the particle and the origin? When x equal 2/3. So if I glance at the graph of this, the graph is not needed, of course. If I look at the graph of this, the graph of a cosine wave at 4, let's say that's 2, that's 4. Period is 2 pi divided by, multiplied by 2 over pi, that's 4 units. So this is 1. There's the graph. So at 2/3, if this is 1, 2/3 is about right there. 2. At that one point, they're asking, how fast is the distance between the particle and the origin changing at this instant? There's the distance, there's s. Well, if I call this, that's x, that's y, so I have s squared equal x squared plus y squared, or s squared equal x squared, and in place of y, it is 16 the cosine squared of pi x over 2. So 2s ds dt equals 2x dx dt plus, bring the power down, that's 32 the cosine of pi over 2x times the derivative of the inside, which is negative the sine of pi over 2x times the derivative of the angle, which is pi over 2 dx dt. Well, here I need a bit more room. I have plenty of room. So I noticed that I could divide by 2, make that a 16. Let's see what each of those are. Well, I'm looking for the s dt. The s dt is going to equal x. The x dt is negative 5 plus 16. The cosine, so x is 2/3, right? Let me fill that in right now. And if I put 2/3 in there, the 2's cancel out. The cosine of pi over 3 is a half times negative the sine of pi over 3 is radical 3 over 2 times pi over 2, and the x dt again is a negative 5. So that becomes a positive, divided by s. What's s? S would be right there. S squared equals 2/3 squared plus 2 squared. That is 4 over 9 plus 4 over 9, 36, 40 over 4, the square root of 40 over 9. The units would be in centimeters per second. And a trout that is 12 feet long, and its ends have the shape of an isosceles triangle that are 5 feet across at the top and have a height of 2 feet. Okay. Feet. Okay, if the trough is being filled with water at a rate of 15 cubic feet per minute, that's how much you're pouring water in. How fast is the water level rising? If I call this water H, what does the H dt equal when H equal 4 inches, well, it's in feet, it's really 1/3 of a foot high. Well, let's see how this works. I know the volume of any prism is 1/3 is area of the base times the height. Volume is area of the base. We're looking at this triangle. The height is a 12. So this is 1/2. This is fixed, that height right there. But the area of the front, well, let's see how that works. That's 1/2 base times height, the base of the liquid. Times the height of the liquid. So volume is 6 times. The height I have information about. The base I need to get rid of. Well, let's see how this works. This is 5. Let me erase that and draw it better. So we know that this is 5. When this is 2. So 5 to 2 equals 'and this is the base to the height. So how do I get rid of the base? Well, I cross multiply. Twice the base equal 5 the height, or the base equal 5/2 the height. And that's pretty much the tricky part of the problem. Once you get that, that is 15h squared. From here on, it's really simple. dv dt is 30h dh dt. And there's nothing to it. dv dt is 15, that's given, it's right there. 30. They said when the height was 4 inches, we said that's 1/3 of a foot. dh dt, that is a 10. Divide by 10 both sides. 15 over 10 is dh dt, or dh dt would be divided by 5, 3/2, and the units would be in feet per minute. So the equation is the hard part. Once you get that done, you're in a very good shape. Last problem. A kite is 75 feet above ground. And moves horizontally at a speed of, let's say this way, dx dt, if I call that x, is 6 feet every second. At what rate is the angle between the string? There's the string. At what rate is the angle between the string and the horizontal decreases when 150 feet of the string has been let out? Well, let's see how we're going to combine those. Now, I need an angle. I need S. And I'm thinking, well, if this is fixed, wouldn't it be easier to get an angle, the adjacent and the hypotenuse? And isn't that tan? Let me see, the adjacent and the hypotenuse, that's cosine. Isn't the cosine of theta equals the adjacent over the hypotenuse? Or S times the cosine of theta equals 75. I'm trying to keep, well, but I have no information. Oh, I see. I have no information about d theta dt is what I'm looking for. The S, I don't have information about, if I take a derivative, I'm going to have the s dt. I don't have that. I have the x dt. Okay, well, what's the other option? Opposite over, can't I say tan of theta equal the opposite over the adjacent? Do I have information about the theta? Yeah, I do. And do I have information about the x? I do. In this case, it does work. So it's 75 tan of theta equal x. And if I take a derivative, I'll get 75 secant square root of theta d theta dt equals dx dt. So 75 d theta dt over cosine square root of theta equals dx dt is 6. So d theta dt is going to equal 6 times the cosine square root of theta over 75, or 6 over 75. And what's the cosine? Well, let's see. If I make this 150, right? And this is 75. Isn't the cosine of theta the adjacent over the hypotenuse squared radians per second? By the way, there was a third equation. I could have said s squared equal x squared plus 75, but that doesn't include theta. So I have multiple options. I need the option that fits my needs. And that's pretty much it for this section.